My wife got me this chocolate the other day. It's actually expensive, like 400 yen. Tastes like your average matcha chocolate. Today, let's talk about LLMs and how local LLMs are starting to catch up, among a lot of other topics as well regarding AI. I have not been using AI that much since 2025 because it would make you tunnel a lot sometimes, especially when debugging. But near the end of 2025 is when I noticed that it got a lot better. But at the same time, nearly half a year into 2026, which is like right now, the frontier AI companies are starting to crapify their services. This means that I think there needs to be a push with local models to be able to run on average consumer grade hardware. It's like, most gaming PCs and stuff, while giving a good amount of quality and speed. That way, it could be an actual replacement to our $20 subs to these AI companies. But yeah, not everyone has $200 a month to shill to a man who said the engineers will be replaced by AI in 2026. See, this was March 2025, 3 to 6 months. So last year, September is when nearly all of code will be written by AI. It means it's been 8 months since AI has replaced software engineers. Oh no, wait, timeout. January of 2026, I guess it's been extended for another year. We're getting off topic anyways. Today I will show a coding example between two models. One is a local model and the other one is going to be by OpenAI. I think it might represent a good idea on how the average gaming PC can handle coding tasks. My gaming PC specs are the RTX 5060 Ti, 16 gigs, Ryzen 7 9700X, and 64 gigabytes of DDR5 RAM. So how I use my local LLM is remotely via Tailscale. I'll go more in depth on this later, but this allows me to use my LLM from anywhere with the internet connection. And when I say frontier level LLMs, this means any model that these big companies provide. While something like Sonnet compared to Opus is like 1 trillion versus 5 trillion parameters. Sonnet compared to the current local LLMs still pale in comparison when you consider the average hardware a person has. But as you can see here, like on a coding index, right? A gemma 4 with 26 bill is still pretty far behind something like Sonnet 4.6, right? It was only relatively recent that like these frontier level LLMs have become reliable enough to use in actual programming tasks. This article here kind of tells a little bit about it, but yeah, it was kind of silent. But yeah, there are various reasons why I think this happened. Essentially, LLMs having access to tools and having a little bit better reasoning. And on top of that, this RLVR training really made these frontier level models evolve suddenly. And it was very shortly after this whole LLM evolution happened that local models also got more reliable, especially with tool utilization. These recent models like quant 3.5 or gemma 4, they have access to tools. So I feel like the local LLM game is starting to catch up. We just need to hit a certain level of reliability with these local LLMs. Like we have Quant 4 and 8 and Turbo Quant as well. But like optimizing it in this way kind of degrades the quality sometimes. So what the trade-off is that, consumer grade hardware can run these kind of large-ish parameter models. But yeah, the hope is that we find a better optimization that won't degrade the quality as much. But yeah, anyways, let me go over briefly the setup that I have. We go to Excalidraw, but this is my Tailscale network. I have my gaming PC, and this has the Llama CPP server, right? And this holds my Gemma 4 26 billion model. So this is all connected to my Tailscale network, right? And this means that in order to use the model, other devices would need to go through the Tailscale network and then hit the gaming PC. Other device would be my Framework 13. This is like my coding PC. If anything happens to this, I'm kind of screwed. But yeah, it has my coding hardness, Pi, and Pi hooks up to my gaming PC. And then I also have my Android phone. This runs Termux, which also allows me to have the Pi coding hardness. This connects to my gaming PC all under my Tailscale network. Typically, my Android phone, I use I live in Japan, so I'm usually pretty bored when I'm on the train. So I might use, the coding harness here to just kind of like research stuff. But yeah, like here, the maker, the creator of Pi, he just commented one day about running Pi in Termux, and then it's just a coincidence that I kind of run Pi on Termux. So screenshot my phone and just reply to it. That is my setup for. This is my setup currently for how I run my local model. The standard pattern I see is people running the local model on their coding PC, right? So this would be like the local model would be hooked up in here, and then they can use their coding harness or any coding harness that they have with it along with it. But I do it differently, where a PC, that's the server, and then I can have other devices interact with it. This means that my gaming PC needs to be on the entire time or whenever I plan to use it. But that's not too big of a deal, since when I'm outside, I just leave my gaming PC on. Maybe I can make another video going in depth in my Pi setup, or maybe how I set up llama.cpp. But yeah, today I'll be demonstrating, the average person attempting to run a local model in order to get some AI assistance with coding. The test demo that I will be doing will mostly focus on output speed rather than quality, because as a software engineer, I think it's our job to correct the LLM after reviewing what it outputs anyways. So we'll mostly just be focusing on how fast the LLM can complete a prompt. This is me from the future. I scrapped a previous test that I made yesterday, and I'm replacing the server. Instead of llama.cpp, I'm using ollama. The reason for this is because I thought of testing it with ollama today and found that I have better results in terms of speed with ollama. And I figured that most people are going to use ollama, so this would be more relatable to use. All right, I'm going to run the new test for Gemma 4, 26 billion quant 4 on ollama and comparing it with chatgpt codex 5.3. So just to run down the task that I wanted to do, currently we have store pattern, like a factory store pattern system here. It looks like the previous artifact is that we have the store factory struct kind of repeated in the other stores. So in the router, we also have this store factory pattern. And essentially, I guess what happened is that it kind of separated the dependencies away from the actual logic here. So essentially what I wanted to do is to move it here, right? Actually, not even here. We would remove this, and it would just be like this, and then this dependency would just get passed into here, because the only place that this dependency is used is to be passed into the core struct logics here. So that's what I wanted to do essentially. I hope my prompt is good enough for it to understand that, but we'll see. I've also made a tool for dynamically editing the agent file. So, because local models kind of need more railguards to properly use tools and stuff. So that's what I have going on here. But yeah, so you see here that we have my local model here hooked up, and let's see, I'll look through my prompts. This is the pre-made prompt for planning. So essentially what I just explained is should be conveyed here, I hope. So let's just let it rip. We also time it as well. So quick. I know it's not scientific, but it will give us a ballpark. Okay, that was quite quick though. That was like 30 seconds of planning. Let's review it really quick. I have no idea what it just said. Ref 10. Well, anyways, so it's gonna move dependencies from store factory to store. I hope it means that it's gonna move it to the this store. We'll see. So this is mostly for speed, not quality. Yeah, let's implement and also time it as well. Okay, it looks like it identified the wildcard here. I definitely see this quite frequently. I'm not too sure how to fix this. Okay, so that's like around 3 minutes. I think it's pretty reasonable, right? Okay, so it looks like it's building properly. Let's check out the difference. This looks correct. This is what I wanted. Yep, just pass it in there. This is also correct. And obviously this works, so took around like 4 minutes total, plan and implement. Pretty good. I know it was a dumb task, but just here to test out if it can follow instructions or not, because the previous models hallucinated quite a bit. But yeah, let's revert this back and go with the frontier model next. Let's first check our agent and file and remove this. We do not need the rail guards for the frontier model. And switch models to 5.3. Yeah, let's just let this rip. I guess the same prompt as before. Let's time it as well. Okay. So 18 seconds. That's a lot faster actually than the previous one. It did call through my scout memory. So it does use tools a lot better. But anyways, let's review it really quick. So delete store factory, looks correct, and then move, yep. Same with the router, and it does the same thing. Then make that go. So yep, all looks good. So we'll implement this really quick. Time it as well. That was incredibly fast, actually. I guess it's because the task was pretty simple. However, I think the planning is pretty comparable. But yeah, let's check out the results. I'm pretty sure it's gonna be the same. Yeah. Oh, except here. I actually don't like this that much. I'd rather just return this, which is kind of strange why 5.3 would do that. Yeah, it does the same pattern here, huh? It's kind of strange. I guess the local model kind of did it better in terms of quality. Yeah, the features can be more complex, so I think the local model might struggle more, but we'll see. Oh, and also we need to change our agent file back to having local rules. So the next task is going to be a API addition. I just need help listing all the posts, and the list will need to be paginated. And the endpoint should just return a pagination model containing the model of posts. Let's just run this really quick. All right, so let's just let it rip. Time it. Okay, so I think it kind of got capped out on its context here. I'm not too sure. All right, so that was like 1minute 44 seconds, which is still reasonable, right, to like create a plan. But let's read the plan really quick. So it's gonna make a generic pagination. This is not that great. You know what? Let's just let it go for now. Let's update the repository layer, so that's good. Yeah, service layer. This is where all the post-related stuff goes into. Actually, no, we probably need like a different service. But anyways, it's just adding on to what we already have, so that's fine. And this will just return, yeah, okay. Clean slate. Let's let it implement. Time it. Obviously, this is not good, but we'll just let it slide for now. Because I could clearly give it like instructions to modify this, like bake it into a different file, but that would kind of ruin the test for comparing against Frontier, because I think Frontier might just one-shot it. I definitely need to find a fix for this. I think this really increases token usage. I'm not too sure though. Interesting. I only needed to like add one thing, but I just kept running into this error for some reason. Definitely if anyone like knows how to guard against this, let me know in the comments. Interesting. It got the name wrong here. Okay, I think it just capped out. Okay, so this time it didn't try to build with go build. Those are 8 minutes. As we can see, more complex tasks is really not that great for local models quite yet. But yeah, let's check out its work. See if it builds really quick. Nope, it did not build correctly. Interesting. There's just like a lot of issues here. Oh, it's because of that. I see. Now it should build. Yeah. Okay. As I said before, software engineers, they are still needed, as you can see. It does add a proper handler to the post, and I guess this would get hooked up to the router, or not even. Interesting. It doesn't even hook it up to the router. No usage. Interesting. It should be here, right? That's what it needs. Like a get. something like this, right? Told it to create the endpoint, but it did not create the endpoint. As you can see, for complex, like medium level complex tasks, I think it's not that great, the local models quite yet. So let's compare this with the frontier model, but I think we'll know how it goes. And let's remove the railguards, and let's switch the model back to 5.3, and we'll just let it rip. Let's also time it as well. So 33 seconds, quite fast. Let's just review it really quick. Definitely has more detail than the local model. Yeah. Okay, let's just let it implement it. And also time it as well. Oh. It's like around a minute to implement. Let's check out the results. Kind of almost the same code as the local one, huh? Or let's also check if it, I mean, I think it does compile. Yeah. Because definitely it checked, it tested itself. But with the list post, I think it should have touch routers, yes. And added this, yeah, correct. Yeah, I can kind of guess. Anyways, yeah, it looks like it did it a lot better than the local model, but definitely I think local models, you know, maybe small refactor or planning, a minute to 3 minutes to plan, I think it's viable. You know, if you're like running out of credits or something, you could definitely offload planning to a local model. Now, am I going to use only local models from now on? No, not really. But with the current enshittification of frontier level subscription plans, I think local models are powerful enough to have planning tasks offloaded to it. And with something like the Pi coding harness, we can just fork that plan session into another session that has the frontier model to pick it up from there. And that way it reduces token usage.